All right, guys, we're starting up our third Cyber Week. This is the last one before we go into spring break, so finish out this week strong. Don't get behind. Don't want you guys having to do work over spring break. We're going to go ahead and get started. Today we are looking at reflecting points on coordinate planes. Now, reflecting in math is similar to reflecting in a mirror. They are the exact same thing. In a mirror, you look and you see the exact same thing. It's just a reversed image. This is the same deal. Whenever you reverse in math, it is going to be the exact same. It's just slightly reversed, meaning either your x coordinate or your y coordinate is reversed, or they are the exact opposite of each other based on an axis. And this is what we're talking about today. There are other things that, reversals happen in math, but today we are specifically focusing on reflecting points in coordinate planes. So let's go ahead and switch over the notes and look at things from there. So, to reflect a point on a coordinate plane, pay attention to which axis the point is being reflected over. Based on the axis you are reflecting over, the new ordered pair of the reflected point will have a reversed x or y coordinate. This is a fancy way of saying whenever you look at the axis you're reflecting across, you're going to have the exact same coordinate on one end. You're just flipping the other one. You're going from positive to negative or from negative to positive. That's it. So let's look at the example here. We have reflect point A across the x-axis. So point A is at 3, 4. Over 3, up 4. Now when we reflect that across the x-axis, we're taking this point and we are flipping it across the x-axis. So we kept our x coordinate, but we flipped it over the y, and that's where our change was made. So we went from 3, 4 to our reflected point A is 3, negative 4. Reflected across the x-axis shows a point keeping the same x coordinate, which was 3, but opposite y coordinates, which we went from 4 to negative 4. That's where the flip was made. We found the opposite y coordinate when flipping over the x-axis. Now let's look at the other one. Point B reflected across the y-axis. Point B is at negative 5, negative 2. Negative 5, negative 2. When we flip it across this y-axis, we make our flip. Our y-coordinate stays the same, negative 2. Our x-coordinate went from negative 5, though, to positive 5. So reflecting across the y-axis shows a point keeping the same y-coordinates but having opposite x-coordinates. Simple enough, right? So here's your assignment for this one. Use graph paper to draw a coordinate plane and plot 10 ordered pairs on those. Now, what I would recommend would be after you have your drawn coordinate plane, keep a little chart over here to keep track of your points. You may want to use wider intervals, like up here. I have just interval of 1 starting from 0. So that would be like 0, negative 1, negative 2, negative 3, negative 4, negative 5, 0, 1, 2, 3, 4, 5, and stuff like that. On graph paper, you're going to have a little bit more room and leniency to, have 10 up top, 10 on the bottom, or even 15 or more. So that's going to help you widen things out. I'm going to explain the assignment a little bit more in the next video because we are running out of time, and we'll see you guys there.